All right. So getting sidetracked one more time. I will get back. I've got a couple different projects I want to get done. One being the Millennium Falcon. I'll give a bit of a where that's at video soon here. But I did have somebody ask. I was doing a video on the Rapid Change ATC, and somebody said that's all fine and well, but how do you do the bit change if you don't have? How do you process a MillMage file with multiple bits if you don't have a Rapid Change ATC? So one of the ways to do that is to export the MillMage file with all separate bits. So if I go into File and I say Save GCode, in this file I basically have two profile paths, one using a 1/4 inch end mill and one using an 1/8 inch end mill. So by default, or as part of the MillMage install, you can go to the presets and you can say something like built-in preset for tools. So what this will do is it will break out and save a file, a GC file, so a GCode file for each end mill. So this can be useful. The other option that you have is by operation, or you can do it by index. So depending on how you want your toolpaths done, you can export them in different ways so that you end up with separate files with the different bits in it. Obviously, if you want to use the M6 command for bit change, you need to export it all in one file and load that into, in my case, what I'll be showing and demonstrating is gSender. So I do have a previous video where I had a tool link setter probe, and I was using the M6 tool change command in gSender. That was before I got my Rapid Change ATC. But I realized that video isn't really that valid anymore because gSender has changed so much. So I thought I would go through some of the gSender options, what those different options mean, and how you can use them. So in my case, I'm going to go to the presets and I'm going to say default project. So this is going to create a single export file, so m6 test.gc, and we're going to export this. Now, I pointed out in my previous video on the post processor, you need to make sure that you enable the tool change options in MillMage to make this work. So how this works is, I'm going to reload this file. So here is the file we just generated. This is the header GCode, so basically setting up the machine positions, whether it's in metric or imperial. M9 is going to turn things off, M5 is going to turn things off, and then we get into our T1 M6. So this is our tool 1 M6 command. So by default, for every bit, it's going to ask for a tool change. So what you can do is, if you are starting the job, is you can go in here and you can delete that first M6. So by doing that, it's going to start the job with whatever tool you load in the machine. So by taking out that M6, you can see below we still have an M6 here for the second tool, but for this first one, we're going to load the 1/4 inch end mill and run the job, and then we'll switch out to the 1/8 inch end mill. So for our test file, that's what I'm doing. Okay. So we go over to gSender, and in gSender, we need to make sure that gSender knows what to do when there's an M6 command. So if I go into the configuration in gSender, you can see there's an option for tool changing. So if I click on tool changing, sorry, I'm just going to make one quick change here. Okay. Sorry, reconnect to the machine. Okay, so you can see by default, I'm not actually sure what the default is. So you can see that here I have pass-through enabled. I have pass-through enabled because Rapid Change ATC includes the macros to run the M6 command. So I'm going to turn the pass-through off, which means that gSender is going to interpret the M6 command. And then if I click on the gSender strategy, you can see that there's an ignore, there's a pause, and then there's a standard rezero, flexible rezero, and a fixed tool sensor, sorry, I should say. So I'm going to focus on these three. So standard rezero, okay, and flexible rezero, and a fixed tool sensor. So I have a tool sensor as part of my rapid ATC. I can use this just as a normal tool setter, and I'll show you that. So I do think for multi-bit, if you're going to do a lot of files with multi-bit, getting a tool setter, even if you don't do the rapid change ATC, just takes a lot of the issues with probing and stuff like that out of the equation, and I highly recommend it. But let's see what happens when we do a standard rezero. So we're going to set this to standard rezero, and I'm going to apply the changes. I'm going to go back to my carve, and we're going to load our file. And the file we want is our M6 test. So we'll load that. So there's really just two changes. I'm just going to do an air carve. So what I'm going to do, I'll show you. Can I do an air carve? Yeah, I can do an air carve. Okay, sorry. So as I was saying, I'm going to do an air carve. I have this job set up currently, and I don't really feel like sorting it all back out. So we're going to use this block of wood. When it goes to do the carving part, I am going to remove the block of wood so that it doesn't carve it. Okay, so right now I am loading up the 1/4" end mill manually into the machine. Just because I'm going to home the machine. I'm not sure what state it's in. Okay, so homing the machine, leave the wrenches out. Okay, so I'm going to bring the machine over to my stock. So we're going to jog over. Get this cable out of the way. Okay, so bring your bit over to the stock. Okay. And we'll bring it down. Okay, so we're aiming for the corner of the stock, which is how I have the job set up. Okay, so I'm going to zero my X and Y. Right. Going to bring that up a little bit and bring it over. So in this example, I'm assuming you have a touch probe. Doing multi-bit without a touch probe, while possible, doesn't make a ton of sense in my head. You could use the paper method, but really at this point, a Z probe is what I would recommend if you want to do multi-tool. So we'll get it close here, and we're going to probe the Z-axis. Touch off. Start probe. Okay, so now we have the X and Y and Z coordinates set for this job. Okay, so we can see in gSender that we have, well, if I go here, we can see in gSender we have a 0 point. It is the top of the stock. I'm only going, set to be going 2 millimeters deep. So all I'm going to do right now is just move this chunk of wood out of the way. And as long as I've done everything right, I'm going to hit start, and it's going to do the first 1/4" bit job, and then it's going to ask me to change the bit. Okay, so I'm going to hit start. Spindle starts up. it's doing that first 2mm profile cut. Okay, so you can see gSender popped up almost right away with the basically the bit change command. So standard re0 tool change detected, stay clear of the machine. Jog your machine to a place you can reach using the jog controls, and ensure that your router and spindle is off and has fully stopped. So great. Okay, so the machine has stopped. I'm going to put my piece of wood back. Okay, I'm going to say complete. So now it is change over to the next tool. Okay, so the directions are on the screen. That window used to look a little bit different. It looks not as good in this this version. Anyway, I'll maybe mention that to CNC Labs. Anyway, you're just following the guide. So this is step 1. So we're going to remove that, and we're going to take, and now I've got my 1/8" end mill. Okay, so I'm going to secure that. Okay, so once that bit is secured, it says we can jog the machine. So in theory, I've just cut some of this, so I want to move over a little bit. So I'm going to use the jog controls on the machine to move over. Maybe bring the Z down so it doesn't have to probe quite as far. And I'll put my touch plate on top of the workpiece. I'm going to say complete. So now it's going to give me the option here. Because of the option that I picked, I have the option to either use my Z touch plate or use a paper method. So in this case, I'm going to use the touch plate. I could have probably moved that spindle down a little further. There we go. So now it's touched off the new surface. And then if we scroll down, it says basically, if everything in the job looks good, prepare your machine to move back to the cutting area and continue as expected. Remove the touch plate. In my case, I'm going to move the stock over, and I'm going to say resume job. So now the spindle is going to start up again. And now it's going to make our smaller 1/8" cut. And it's going to stop the job. Job's complete. Life is good. So at this point, the M6 command is working. It's doing everything that I expect it to in this case. So what I would like to do is go over one of the other options, and then, like I said, I'll use the tool setter as the last option and show you why I think I think at the very least, if you're going to use the M6 command to do tool changes, that you should get yourself a tool length sensor. I built one. I'll put a link to it. It's from the Milo Mill project, and they have basically it's a Z probe for a 3D printer that they've adapted to the CNC machine. It works fantastic, and it costs about, I mean, if you build it yourself, it probably costs pennies. If you buy their kit, I think it's, $30, $40. Okay, so in this case, we're going to go back into config in gSender and click tool changing. So in that case, we use standard re0. So let's go ahead and use flexible re0. So flexible re0, if you read it, is similar, but uses a touch plate like a tool length sensor. So instead of having to probe Z like we did and giving us the option for the paper, it's just going to assume we have a touch plate and use it like a tool length sensor. So that sounds pretty helpful to me. So again, we will set up our job like normal. We'll verify that our X and Y is still good. So because of the way that it treats the probe when it's in this mode, it was conflicting with the fact I have a tool link sensor connected. It didn't like that, basically. Okay, so again, we're going to start this job, but pretend I have a 1/4 inch end mill. Well, this one should work, so why don't I switch it? And this is why you get the rapid change ATC and save yourself having to put the bits in and out manually. Okay. Oops. Okay, so now you've got your 1/4 inch end mill. We've got X and Y done. We'll zero out the Z axis here. Okay, so that's all done. Job's ready to start. I'll move my stock out of the way and we're going to hit start. Okay. So it says again, make sure that everything is stopped spinning. Move the bit to somewhere that you can probe. Again, I was about to do what I'm not supposed to do. Again, move your bit somewhere where it can be. Don't take out your current bit. Go to the next step, which is to probe your initial tool. So again, we'll grab the probe. It says to bring it down to about 0.4 inches. So we're going to bring it down over the probe. Probe initial tool. So it's currently measuring the tool we have. Okay, so that's done. So now it says jog your machine to somewhere that you can reach and change your tool. So in my case, I'm just going to raise this up a little bit more. Pull out the 1/4 inch end mill. Install the 1/8 inch end mill. Tighten things back up. And then it says bring it back down to about 0.4 inches above your material again. So we'll do that. And we're going to say probe changed tool now. Again, it's going to bring the spindle down. Perfect. Okay, so now we have that done. Basically, it's going to say make sure that everything is out of the way and that you're ready to resume. I'll move my stock. I'm going to say resume cutting. Okay, so there we go. So then our 1/4 inch job or 1/8 inch job is done and the program has finished. That is the other option for tool changing. So now we've gone through the standard, which basically allows you to use the plate or use the paper method. We've used flexible re-zero, which is similar but requires the touch plate, not the paper method. And the last one is to use a fixed tool sensor. So if I pick this one and I hit apply, we'll see some additional options here. So basically what we would need to do is jog the machine over to our sensor. So in my case, pointing and not in the right spot. So in my case, this is my tool length sensor. So this is part of the rapid change ATC. So this is where we would want the machine to come to do the measurement after the tool change. Okay, so basically what we're going to do is I'm going to apply that, leave it at fixed sensor, and we're going to go back to the car screen. Now, because of the change I have to make, because of the issue with the tool length sensor, I need to reset the controller and plug the tool length sensor back in, so I'll do that now. Okay, so now I've got that reset. Let's go to connect to the machine here. Okay, so we'll home the machine. So again, this is now my tool length sensor. So we're going to use the probe on the initial probe the workpiece. And then when we do the M6, it's going to use the tool length sensor to take the measurement. So home the machine. We'll return back to our X and Y. We'll come in a little bit. Now technically the 1/4 inch end mill is supposed to be first, but in the expedience of time, because this video is already going to be too long, I'm going to use the 1/8 inch end mill. So again, I'm going to get my touch probe, my touch plate, going to get it close, probe, have to do the initial touch off, and start probe. Okay, done. So now the initial tool is probed. I'm going to move the workpiece out of the way. I'm going to hit start job. So spindle's going to come up. Again, you can see in gSender that the tool length sensor page is already up. All right. So it's going to come all the way up, and it's going to head over to probe the initial tool. So now it's over where the tool sensor is, and I have to press the probe initial tool button. So I'm going to do that. So it's going to, so the tool length sensor, I have this height probably set a little bit high, which means it's got to seek down quite a ways. I'll have to clean that up after. Oh. Okay, so now it's done that. So I'm going to change the tool as recommended. I guess it's required in the case of this job. So I'm going to swap out my 1/8 inch end mill to my 1/4 inch end mill, which is of course backwards for what we wanted, but good for demonstration. Okay. Once the bit is secure, we can say probe change tool now. So again, it's going to seek down. Should adjust that seek speed. Okay, so now that is complete. It has measured the first tool and now the change tool, and I can click the resume button. Once you tap resume, the spindle will move back to where the operation's happening. Get the spindle up to speed, or turn your router back on in case you have a router, and it will finish that cut at the new height. All right, and now the job completes. So those are basically the 3 ways. So again, if I go config and I go tool changing, those are the 3 different options. There is a 4th option, which is code, which is if you have something outside of the rapid change ATC, something more custom built, you can actually write GCode to make this more automated as well. So if you built your own rapid change ATC, you could use the code option to kick that off. So just note there are lots of different options, but we went through the standard ReZero, the flexible ReZero, and the fixed tool sensor. So hopefully that's helpful. And like I said, this is kind of updated from my previous video, now using gSender 1.56. I think the old video was using gSender 1.48. So hopefully that information is helpful. Sorry for the small tool length sensor glitch in the middle there. I'll try to clean that up or make that as go by as quick as possible. But yeah, those are the 3 different options that you can use with a touch plate. But like I said, it doesn't have to be part of the Rapid Change ATC. I don't have my little clicker here. I don't think. Oh, yeah, it's kind of like this. Basically, it's like this. So not the orange piece outside, but this little orange piece. And basically it's just a little micro switch. So yeah, you can build one of these pretty cheaply. There's lots of different options on printables and some of the other 3D printed file sharing sites for tool length sensors. And they work good. You can definitely buy one on Amazon or you can get pretty fancy with them. But yeah, my little micro switch version worked quite well for me. And the one on the Rapid Change ATC works awesome as well. So definitely, I think worth having if you're going to get into bit changes. Getting a tool length sensor does speed things up, does take some of the error, especially if you're doing 3D carving where you might not have anywhere else to probe off of. The tool length sensor really saves your butt that way. Because if this was a 3D carve and it was all carved up and rough cut, I'd have nowhere to probe from. So a tool length sensor really is your only option to get a good height match between the different bit changes. So if you're going to use M6, I do recommend both a touch plate and a tool length sensor, in my humble opinion. Definitely lots of different ways to do it, but that would be my 2 cents. Okay, like I said, hopefully this was useful. Definitely was long enough, and we'll see you in the next video. Thanks, guys.